so today we're talking about proportional odds logistic regression and going through some of the R code for how we can actually assess that key assumption in this model, which is that the odds are proportional, which basically just means that the odds ratio between any two levels of a covariate is going to be the same regardless of where we draw the line for that ordinal outcome. And so the data set we used here, and there's a link for it in the blog post, is this 2011 annual residence survey from Durham, North Carolina. And I just found it on data.world, and it seems sufficient for what I was trying to do here. So you can see some information about it. The purpose of this annual city-county survey was to objectively assess citizen satisfaction. You scroll down, there's a number of different questions here. And usually these kind of websites, if you poke around a little bit, you can find a way to get the right link so you can just import it directly into R or Python or whatever directly from the web. And so if you click this little download button and click the share URL, you'll get this little window that pops up, switch to R, and there's a little code snippet for you to just pull the data straight from the website. Okay, so we're in our studio now, and all this code is going to be available right on the blog webpage, and so you can find all of it there. So the first thing we're going to do is load the tidyverse package, get all the functions we need, and then we're going to go ahead and read in the data set. And so we're just using this link that we got directly from the data.world website, and we're going to use the read to lim function from the readr package, and then we're just going to go down and clean it up right away. And so what we're actually trying to do here is model this survey question, the quality of life in the city, and which has possible answers: very dissatisfied, dissatisfied, neutral, satisfied, or very satisfied. And we're trying to see if it's associated with age, and we want to adjust for income and sex. And so here we're just cleaning up the data, and we end up just removing some random missing cases. Makes it easier for demonstration purposes. So if we run that, it's going to go out to the website, pull it in, and then we get something like this. And so there's 365 responses, and you can see the age. It's not a numeric age value. It's just age ranges, and then we have income, and then we have sex. All right, and so the first thing we want to do is see what the outcome distribution looks like to kind of get a feel for what kind of volumes we're dealing with in these different categories. And so here we're just going through getting group counts by the outcome and the age factor, and making a ggplot. And so let's run that. And I guess it takes a minute. All right, so what we can see here, the age category is on the x-axis, and then we have the number of respondents on the y-axis, and we have it colored by their response to this question of perceived quality of life in the city. And so one thing that kind of starts to stick out right away is the blue rectangles especially, which corresponds to dissatisfied, and relative to the bar as a whole, it starts to take up a larger proportion with older age. And so we might kind of suspect, and kind of maybe make sense to think that older respondents might overall on average have a kind of more pessimistic view of quality of life in the city for whatever reason. And so it kind of starts to make sense. But so one thing we might be expecting to see when we look at the relationship between age and this outcome in a model might be that older patients tend to have worse outcomes than younger patients. So that's kind of what we're seeing and what might make sense, and we'll see kind of how that plays out. All right, and so the next step, we're actually going to fit our model, and we're using this polar function from the mass package, and just specifying our formula just like we would with any GLM or linear model or anything like that. Our quality of life variable is this ordered factor, and that's our response, and we're regressing it on age, income, and sex. And just before we do that, we'll just take a look at this quality of life factor, and we can see there's only 7 very dissatisfied responses, and most people said satisfied, and we can see that in the bars as well. Alright, so fit that model, and then we want to see what those coefficients say. And so here we're just extracting the model coefficients, getting some confidence intervals, and making it look nice to form a table. So we can run that. Alright, and so here's our age levels, and then our odds ratio estimates, and our lower and upper bound of our confidence intervals. And so in this model, all of our age categories are comparing to the youngest age group, 18 to 34-year-olds, as the reference category. So when we interpret these odds ratios, it's each group compared to that reference group. And so in this current proportional odds model, we see, for example, 35 to 44-year-olds, the odds of we can just say, more pessimistic response is 1.24 times the odds of a younger respondent responding more pessimistically. And so got to be careful with the direction of some of these things when you're working with the proportional odds models. I think in some other implementations they might kind of by default go in the opposite direction, and so here I just had to invert stuff here to make sure it was going in the direction that I wanted it to, just for interpretation's sake. The estimates themselves will always kind of be the same or mean the same thing. It's just got to make sure that they're pointing in the direction that you think they are when you're interpreting them. But overall, some of these kind of make sense from what we saw in that bar plot earlier, specifically the 65 to 74-year-olds. The odds of a say more pessimistic view of quality of life in the city is 3 times that of the youngest age group. And of course the confidence interval going from 1.4 to 6.5. And so we're starting to see some signal that older age groups tend to respond maybe more negatively on average than the youngest age group. So the question here is, we said that the proportional odds model itself has this assumption baked in that the odds are proportional basically regardless of where we draw this line in the response variable. And so what we're saying here is, for example, let's just say I'm going to bring up the response levels again. So what this model is saying is that if we drew the line here, so we compared very dissatisfied to a combination of dissatisfied or neutral or satisfied or very satisfied, we're saying the odds of a 65 to 74-year-old responding very dissatisfied versus anything else is 3 times the odds that an 18 to 34-year-old would respond very dissatisfied versus anything else. So then the assumption is that, okay, now if I drew the line here in between dissatisfied and neutral and said, okay, what are the odds that a 65 to 74-year-old responds very dissatisfied or dissatisfied versus everything else? We're assuming that this odds ratio holds for that comparison as well. And then also all the other ones. So very dissatisfied, dissatisfied, and neutral versus satisfied and very dissatisfied. And then the last one, very dissatisfied through satisfied versus very satisfied. And so it's kind of a big assumption that kind of all these different ordinal groupings would hold in terms of having the same odds ratio, but that's what it means to be or to have proportional odds. And so the point of this blog post was, how can we do a simple check to see if that holds reasonably? And one way we can do that is, well, how we just described all these different comparisons is we're kind of drawing lines between each category, making these two binary groups, right? And so we can think of, okay, so right now it's all summarized into a single odds ratio. Well, what if we free up that constraint and we actually just make a bunch of different binary models and see, do we see kind of a similar odds ratio when we have a bunch of separate models? And if they are all kind of similar, then we can reasonably conclude that, okay, the odds seem to be relatively proportional, and it's much easier from a statistical perspective and a practical interpretation of the results to be able to summarize things in a single model than have a bunch of other models floating around and trying to untangle what it all means when there's 5 different odds ratio estimates per group against a single reference category, and so it becomes a mess. But when you're working with these models, you definitely want to check this assumption, because when you fit the model, you're going to get a single estimate no matter what, and it's kind of up to you to figure out if that number makes sense or not. So the next part here, we're going to go through and actually do exactly that. We're going to find the figure out the number of comparisons we're going to make, and so we have 5 levels, and so we're going to make 4 different models that are all going to kind of be different binary outcomes defined, and then within each one of those we're going to fit just a standard binary logistic regression model, compute the odds ratio, and then we're going to plot it and see how similar or different they are across all those models. Alright, so here we're just figuring out how many comparisons we need to make. There's 4. And now for each of those comparisons, we're just going to go through and run through this process, kind of repeat the same thing for each one of those comparisons. And so all we're doing is kind of just indexing the levels so we get the right groupings, and we can, for example, let's just set this to what does the first grouping look like, and we'll run through what one iteration of this looks like. So when we start at the first index, we're saying we're going to get the first response, which is the first level, very dissatisfied. And then we're going to come down here and say, okay, when the quality of life variable is in this group of temp response, it's 1, otherwise it's 0. So we're creating this binary response. And we get something like this. And so if we look at that new response compared with the full response variable, we'll see that everybody with a 0 is either dissatisfied through very satisfied. Everyone with a 1 is all this very dissatisfied group. And so as we iterate through all these index values, we're just going to end up having all the different groupings that we need. Okay, so the next step then, we want to just fit a standard logistic regression model using that binary response, and again regressing it on age, income, and sex. And so now we're just predicting whether somebody responded very dissatisfied or anything else. And then we're going to compute the odds ratio for that comparison. And so this code chunk here is just going to basically repeat what we did above with the proportional odds model, basically the same code. And we are just getting the odds ratio, doing some formatting, and then making a column. And then after we repeat that for all the different combinations of our binary models that we're testing, we're going to pull it all together. Again, some more cleanup, and then we're going to make our plot. And so our plot's going to be, for each age category, we're going to have a different odds ratio estimate for each of those 4 different binary outcome models, and we just want to see how similar or different are they across all of those models. And so that's what this code does here. All right, so let's run that. Okay, and so like we said, we have a panel for each of those age categories, and we added this first panel here just to again show that this age group 18 to 34 years is always the reference category, and so that's what all of these estimates are always being compared against. And so on the x-axis we have those the response values for each of those 4 models, and so for this first one, very dissatisfied, this would be the odds ratio for the binary outcome model of very dissatisfied versus everything else. For the dissatisfied estimate, we're comparing very dissatisfied or dissatisfied versus anything above that. For the neutral, it's very dissatisfied, or neutral versus satisfied or very satisfied. And then finally, this satisfied odds ratio is the binary outcome of very dissatisfied, neutral, or satisfied versus very satisfied. And so I think one thing that sticks out right away is, and I guess one other thing I'll add quick is the shaded areas represent the 95% confidence intervals, and so I guess that's the first thing you see is that these are all pretty wide here, especially in these first couple models where very dissatisfied is its own level in the binary outcome, and from what we saw before, there's only 7 responses as a whole in this category, and so our estimates kind of are pretty highly variable. But anyway, so the thing that sticks out to me right away is the 64 to 74 years. it actually looks relatively consistent across these different binary models. It's just varying between, say, 2.5 and 3.5, somewhere around there. But what that's telling us is that no matter how we kind of break up our ordinal response, we tend to see this age group have this 2 to 3 times higher odds of responding, say, more pessimistically than this lower age group. And so for that category on its own, I would probably say that the proportional odds assumption is reasonable, and we can probably carry on with that model, especially for the sake of simpler summarization interpretation. But these other age groups, it seems to be tell a different story. And so when we're just looking at the binary outcome of very dissatisfied versus everything else, we tend to see higher odds ratios in these age groups compared to the younger age group. For the 35 to 44-year-olds, it's around 3. For the 55 to 64-year-olds, it's also around 3. Again, the high variability, it's kind of adding a lot of noise here, but in any case, it sort of seems like overall, on average, older respondents are more likely to respond more unfavorably than the younger age groups. But we kind of see it decrease across these models with these age groups. So the 35 to 44 years kind of seems to have this decline. 55 to 64 kind of has this decline. And the way I kind of was rationalizing that was something like older respondents may be more likely to want to state their dissatisfaction to a question like this, maybe more than they may be more likely to say they're very dissatisfied or dissatisfied compared to the younger age groups than making a huge deal to differentiate between satisfied and very satisfied. There's not as big of a difference to people between being satisfied and very satisfied about this particular question. So for example, like this 1.0 roughly odds ratio here for the 55 to 64 years on this satisfied binary outcome is saying the odds of a 55 to 64-year-old responding very dissatisfied, neutral, or satisfied versus very satisfied is basically about the same as a younger respondent. And it kind of makes sense. There's doesn't seem to be like a big gap between, or any kind of reason why there would be a big difference between those two groups. And so for me, looking at this, I would say there's probably more work to do, that the proportional odds assumption overall is probably not satisfied here, especially if we have some sort of practical justification that makes sense for why it's not necessarily a reasonable assumption. And so you might need to go back to the drawing board a little bit and think about how you can introduce some more complexity into your model to better capture some of these trends or relationships. So one option might be, to start at least, is to just stick with this big collection of binary models and say that and start to summarize and interpret your results that way. You just kind of have all these different odds ratios floating around, but that's kind of what leaves the most flexibility to capture the trends that are in the data. And so that's what you might need to do. But you also might be able to think of how you could model some sort of interaction in here, or things like that. So, but overall, just the simple proportional odds model we ran to start this is probably not sufficient. And then the last thing I was going to say is, again, we're only looking at or assessing the proportional odds assumption here for the age factor, but that same assumption also holds for the other two variables that are in our model, which was income and sex. And so even though we're looking to see what odds ratios are for age, we also have that same proportional odds assumption for everything else that's in our model. And so we would, in practice, want to test what those are too. And so if we can take a quick look at what those are. And I'm just going to kind of ballpark some things here, but so for males versus females, for example, this is our coefficient. So the odds ratio is 0.88, and so that's saying that the odds of a more unfavorable response to the question of perceived quality of life is lower for males than females, and again, it's assuming, and it's about 12% lower, and so again, our model is assuming that that's also the same across all those binary models where we draw the line across the ordinal response. And then for income, we kind of have this increasing trend in our odds ratios. So anyway, those are also some things you would want to assess.